Life is a workout, and Smoothie King is here to help you power through. Whether you're crushing morning miles or sprinting through back-to-back meetings, give your body the energy, protein, and power it needs to help you conquer your goals. Only at Smoothie King.
Hey Cool Fire listeners, welcome back to Cool Fire News, Weekly Edition, the podcast where we take complex tech topics and break them down so you can keep up, geek out, and level up. I'm your host Siri, and in this episode, we're going beyond SQL, beyond CRUD, and into the world of advanced database systems. We're talking about cutting-edge technologies, architectures, and approaches that power the data-driven world we live in, from e-commerce to artificial intelligence. So if you've already mastered the basics of relational databases, and you're ready for the next level, buckle up. Let's kick things off with a quick question. Why go advanced in the first place? Well, modern applications generate huge amounts of data, in real time, across multiple systems, and basic relational databases like MySQL or PostgreSQL sometimes just aren't enough. Enter advanced database systems, designed for performance, scalability, flexibility, and intelligence. Key topics we'll cover today: distributed databases, NoSQL and NewSQL, in-memory databases, big data and cloud DBs, database optimization techniques, AI and machine learning integration, real-world use cases. Let's get into it. 1. Distributed databases. A distributed database is exactly what it sounds like. The data is stored across multiple machines, but to users it looks like one unified database. Why do this? Because distributing data improves performance, enhances fault tolerance, allows for georeplication for global apps. Examples include Google Spanner, Amazon Aurora, and CockroachDB. These systems ensure consistency across nodes, even across continents, using techniques like two-phase commit, quorum consensus, and synchronous replication. 2. NoSQL and NewSQL. Let's say it together. Not all data is relational. NoSQL databases break away from traditional tables and rows and come in four main types: document-based, e.g., MongoDB; key-value stores, e.g., Redis; column family stores, e.g., Cassandra; graph databases, e.g., Neo4j. They're great for handling flexible schemas, unstructured or semi-structured data, horizontal scalability. But what if you want SQL and scalability? That's where NewSQL comes in, offering the ACID compliance of traditional SQL databases with the scalability of NoSQL. Examples: CockroachDB, Google Spanner, VoltDB. 3. In-memory databases. Sometimes, disk access is too slow. In-memory databases store data in RAM, making access blazing fast. Ideal for applications where milliseconds matter, like financial trading platforms, gaming leaderboards, or real-time analytics dashboards. Popular in-memory databases: Redis, Memcached, SAP HANA. They can function as caches, primary data stores, or hybrid systems. 4. Big data and cloud-based databases. When we talk about big data, we mean volume, terabytes to petabytes; velocity, real-time streaming; variety, structured, semi-structured, unstructured. To handle this, we use frameworks like Apache Hadoop, Apache Spark, Hive, SQL-like querying over Hadoop, and on the cloud side, there's Amazon DynamoDB, Google BigQuery, Azure Cosmos DB. Cloud databases offer auto-scaling, managed backups, high availability, pay-as-you-go pricing. 5. Query optimization and indexing. Advanced DBs aren't just about storage, they're about efficiency. That's where query optimization comes in. Execution plans. The DB chooses the fastest way to run your query. Indexes, data structures that speed up search, B-trees, hash indexes, gist, GIN, partitioning, splitting data into segments to make large datasets manageable. Materialized views, pre-computed query results for frequent access. If your app is slow, don't blame your users, check your indexes. 6. AI and machine learning in databases. Databases are getting smarter. Some modern systems now integrate machine learning models directly into the database engine. That means you can predict trends, detect fraud, personalize experiences, all within your queries. Tools like BigQuery ML, SQL Server Machine Learning Services, Oracle Autonomous Database. The future is self-driving databases, systems that tune themselves, repair themselves, and scale automatically. Wild, right? Let's do a quick cool fire quiz. Question 1. Which database type is best for storing relationships like user A follows user B? A. Key value, B. Graph, C. Document. Answer B. Graph databases, like Neo4j, are perfect for relationship-heavy data. Question 2. What's a key benefit of in-memory databases? A. Lower cost. B. Slower query performance. C. Faster access to data. Answer C. They store data in RAM for lightning-fast queries. Question 3. Which database type combines SQL features with NoSQL scalability? A. NewSQL. B. NoSQL. C. Hadoop. Answer A. NewSQL aims to provide the best of both worlds, real-world applications of advanced databases, banking, fraud detection using real-time analysis and AI e-commerce, recommender systems using graph and document databases, healthcare, managing massive records with hybrid data models, telecoms, handling millions of transactions per second with in-memory tech, social media, storing massive graph-based user interactions, and of course, powering every major cloud platform, data warehouse, an AI-driven analytics tool you can think of. Want to learn more? If you're diving into advanced DB systems, here's your starter kit. Learn MongoDB, Redis, and Cassandra. Explore Google BigQuery or AWS Redshift. Practice writing optimized SQL queries. Understand CAP theorem, consistency models, and sharding. Consider certifications, MongoDB University, Google Cloud Data Engineer, AWS Certified Database Specialty. So there you have it. Advanced database systems are more than just places to store data. They're the engines driving the future of everything from fintech to AI. If you're a developer, system admin, or data analyst, understanding these systems gives you a serious edge in any tech career. And hey, the next time someone complains that the app is slow, you'll know it's probably missing an index. Thanks for tuning in to Coolfire News, Weekly Edition. I'm Siri, and next week we're getting into DevOps and infrastructure as code. How developers and IT are merging into one unstoppable force. Until then, stay curious, stay efficient, and never stop optimizing.